Hello students. Till now I have discussed about two types of methods for solving linear programming problem. They were graphical method and simplex method. So in simplex method I also discussed various types of problems like maximization problem, minimization problem, and in one of those problems I also told you when will the unbounded solution type of case comes. So in this lecture I'll be discussing about degeneracy in simplex method. So what is degeneracy and how to solve these type of problems we'll see in this lecture, and I'll take up a question. I will solve that question stepwise, and I'll tell you when I'll be solving stepwise, I'll be telling you what is degeneracy and how I'll be solving that type of LPP. So let me take a question. So here is a question of linear programming problem where the objective function, where I have to maximize the objective function, and the objective function is 2x1 plus x2, which is subjected to three inequality constraint equations. They are 4x1 plus 3x2 less than or equal to 12, 4x1 plus x2 less than or equal to 8, 4x1 minus x2 less than or equal to 8, and where x1 and x2 greater than or equal to 0. Now one modification I want to make in this lecture that I have not told you, or I have incorrectly used the term in the previous lectures, and that is about the basic variables. So in the previous lectures I mentioned the term that basic variables means all the variables present in the linear programming problem like x1, x2 and all the slack variables or surplus variables, whichever you take. But the modification is that it is not like this. There the variables, basically we have the variables in the linear programming problem, like all the types of variables are x1, x2 and whatever slack, that is s1, s2 or surplus variables, whichever you use. These are all the normal variables. Now they are divided into two categories like basic variables and non-basic variables. So the variables which are already present in the linear programming problem, they are called non-basic variables, and the variables which we introduce in the question like slack variables or surplus variables that we designate using s1, s2, s3, those variables will be called basic variables. So this is the modification. You just kindly make this modification in your previous lectures also. And one more concept that I'll be introducing while solving this question, this concept, whether you use it in your previous lecture or not, it is just to make you understand that why and when we use the simplex method and what is the limitation of simplex method. When we will know that this simplex method is not going to get applied in this problem, that concept I'll discuss in this question, and that concept is also valid for all the previous simplex method problems that I've solved in the previous video lecture. So moving ahead with the solution of this lecture, okay, what we do in case of simplex method, we convert all the inequality constraint equations into the equation form that I have done in this slide. So I have converted all the three inequality constraint equations, that is 4x1 plus 3x2 less than or equal to 12, 4x1 plus x2 less than or equal to 8, 4x1 minus x2 less than or equal to 8. Since all these inequality constraints are less than or equal to type, so we will be adding a slack variable to convert this inequality constraint equations into the equation form that we have already done, that we have already seen in the previous problems also. So by adding slack variable, I have converted those three inequality constraint equations into this equation form. So now how many variables are present in this linear programming problem? There are 6 variables, where x1 and x2 are the non-basic variables. They were already present in the LPP. यानी कि linear programming problem, and the remaining S1, S2 and S3, they are the newly introduced slack variables and they are called the basic variables. So next what I'll be doing, this is my objective function was 2x1, z is equal to 2x1 plus x2. So I'll be introducing the newly introduced slack variables in my objective function also, same as we have done in the previous questions. So I have introduced the newly introduced slack variables s1, s2, s3 with the coefficient 0 in the objective function, and now my objective function is, we have to newly modified objective function is z is equal to 2x1 plus x2 plus 0s1 plus 0s2 plus 0s3. Okay, this is the concept that I'm going to discuss in this lecture, that is about initial basic feasible solution. It will be applied to all the previous simplex method problem also. What is this concept? First we will put all the non-basic variables, means all the variables which were already present in the LPP. We will make all the non-basic variables to be equal to 0, and after putting all the non-basic variables equal to 0 in all the three equations, constraint equations, we'll find S1, S2, S3. Now if I put x1 and x2 0 in all the three equations, if I put x1, x2 and x1 and x2 to be 0, then what I will get from equation 1, I'll get s1 is equal to 12, from equation 2 I'll get s2 is equal to 8, and from equation 3 I'll get s3 is equal to 8. So here I need to see whether the value after putting non-basic variable equal to 0 in the constraint equations, whether the value of basic variable comes out to be positive or not. If it comes out to be positive, then only we're going to use the simplex method. If it doesn't comes out to be positive, we'll discuss in the next lecture how we're going to solve such type of problems, what method we will use. So we'll continue in the next video lecture. I'm ending this class here.